Let's use the product rule to find the derivative of x to the 5th power times the natural log of x. And right here, we just have our product rule written down. So let's go ahead and divide this into 4 parts. So here's 1, 2, 3, and 4. So we know the 4 things that we're going to need are f of x, g of x, f prime of x, and g prime of x. So we know our first function, f of x, is just x to the 5th power, and our second function, or g of x, is just the natural log of x. So let's take the derivative of f of x, which would be 5x to the 4th power, and then the derivative of the natural log of x will always just be 1 over x. Sorry, that's a 2. 1 over x. Okay, so let's just go ahead and plug all of that back in. So we have f of x, which is x to the 5th power, times our g prime of x, which is 1 over x, plus f prime of x, which is 5x to the 4th power, times g of x, which is the natural log of x. So this right here would be our answer, but if you are required to simplify further, you just times these two together. Let me scroll down. And if you times those two together, you would get x to the 5th power over x, which would simplify to x to the 4th power. So our final answer would be x to the 4th power plus 5x to the 4th power times the natural log of x. That is our final answer for this one. For this example, we'll still use the product rule, but this time we're going to solve for the derivative of sine x times 4x cubed. Again, this right here is our product rule, and we're dividing it to 4 parts again. We need f of x, g of x, f prime of x, and g prime of x. So we know f of x, our first function right here, is just sine of x, and g of x, our second function right here, 4x cubed. So let's get the derivative of each of these. So the derivative of sine x will always be cosine x. It would be a good idea to remember that. And the derivative of 4x cubed would be 12x squared. And if we just plug that back in, we would get sine x times 12x squared plus cosine x times 4x cubed. And there are no other like terms, so you can't simplify further than this. So this right here would be our final answer. Okay, the last one was pretty basic, pretty simple. This one's going to be a little bit more complicated, or just longer. So again, here we have our product rule, and we are going to divide it into 4 parts because there are only 2 functions. So we have f of x, g of x, and the derivative of both of those. So we know f of x is our first function, which is right here, dx. And g of x is right here, our second function, 9x minus 1. So the derivative of ex will always be itself, dx. That would also be something important to remember. And the derivative of 9x minus 1 is just going to be 9. So again, we're just going to plug everything in, which should give us ex times 9 plus ex times 9x minus 1. And this right here would be the correct answer, but if you wanted to simplify, because you can simplify further, it would look like this. We would have 9 times ex is 9ex plus 9x ex minus ex, which would simplify further to 8 plus 9x So if you're required to simplify this right here would be our final answer. So it actually really wasn't that complicated, just a bit more length from the previous example. Okay, let's use the product rule again, which remember is denoted by this right here, to solve for the derivative of x cubed plus 9x minus 1 times 10x plus 3. So again, we're going to divide it into 4 parts, f of x, g of x, and both of their derivatives. So f of x is just our first function right here, x cubed plus 9x minus 1. G of x, our second function, is right here, 10x plus 3. And then we need the derivative of both of those, so the derivative of f of x would be 3x squared plus 9, and the derivative of g of x would just be 10. Okay, so if we plug all of that back in, remember we need f of x, which is x cubed plus 9x minus 1 times g prime of x, which is 10, plus f prime of x right here, 3x squared plus 9 times g of x, which is 10x plus 3. And this answer right here would be right, but if you're required to simplify, there's a bit more work to do. So let me scroll down. Okay, so this is where a lot of students mess up. They just mess up like terms or don't combine the right way, so we'll go slow. So first we need to, let's just work with this half right here. Let's just distribute this 10 to each of these terms. So we would get 30x, the 10 times the x cubed would just be 10x cubed. The 10 times the 9x would be 90x, and the 10 times the negative 1 would be minus 10. Okay, so we've done that half. Now let's move on to this half. So the 3x squared times the 10x would give us 30x cubed. And the 3x squared times the 3 would give us 9x squared. And then the 9 times the 10x would give us 90x. The 9 times the 3 would give us 27. Okay, so we have like terms right here with the 10x cubed, 30x cubed, which would give us 40x cubed. And then we have like terms with the 90x and the 90x, which would give us 180x. And then we have like terms with the negative 10 and the 27, which would give us plus 17. And then we have like terms, we only have the 9x squared and it has no like terms, so we would just add that at the end. Okay, so after simplifying, our final answer would be 40x cubed plus 180x plus 17 plus 9x squared. For this example, we'll still be using the product rule, but this time to solve for the derivative of 6x to the power of 3/2 times tangent x. So again, we have 4 parts, f of x, g of x, and the derivative of both. So this right here is our first function, which is f of x, so we can write that down here. And tangent x, it will be our g of x. So if we take the derivative of both, starting with f of x, we would get 18/2, because that's what you get when you multiply 6 times 3/2. And then if we subtract 1 from our original exponent, we would get 1/2. Excuse me. And if you can't see it, this simplifies further to 9x to the power of 1/2. And the derivative of tangent x is just secant squared x, and this will always be true. I would focus on memorizing this. Normally in calculus, they mostly only use cosine and sine, but I would still focus on remembering the derivative of tangent x, just so you already have that information when you ultimately come across that one day. So if we plug that all back into our original function, we would get, not our original function, our original formula or product rule right there, we would get 6x to the power of 3/2, and then times g prime of x would be times secant squared x plus f prime of x, which would be 9x to the power of 1/2 times g of x, which is tangent x. And there are no more like terms and no way to simplify this further, so this right here would be our final answer. For this example, we'll use the product rule to solve for the derivative of 70x sine x. So same thing, 4 parts, f of x, g of x, and the derivatives. So f of x right here is 7ex, g of x, sine x right here. The derivative of 70x is 70x. Remember, the derivative of ex is always going to be itself, and the derivative of sine x equals cosine x. Again, work on remembering the derivatives of sine x, cosine, and tangent. So if we plug that back in, we would get f of x, which is 70x, times g prime of x, which is cosine x, plus f prime of x, which is 70x again, times g of x, which is sine x. And this answer would be right, but you could simplify further because you have these in common right here. So you can just pull that out, 70x times cosine x plus sine x. So either of these would be correct, but this one right here is the most simplified version. And for our final example, we're going to use the product rule one last time to find the derivative of 3x to the 5th power times 1 minus x. So remember, this right here is our first function, this right here is our second function. So if we plug that in, f of x would be 3x to the 5th power, g of x would just be 1 minus x. And the derivative of f of x would be 15x to the 4th power. If you're wondering how I got that, I just times 3 times the 5 and subtracted 1 from the exponent. And the derivative of g of x, 1 minus x, would just be -1. If you're wondering why it's -1, not +1, it's because the derivative of 1 is just 0, but the derivative of -x is -1. So that would just leave -1 in case you got lost there. So if we plug that back in, we have f of x, which is 3x to the 5th power, times g prime of x, which is -1, plus right here f prime of x, which is 15x to the 4th power, times g of x, which is 1 minus x. And this right here is the correct answer, but it can be simplified further than this. And me personally, I would get into the habit of simplifying as much as you can because most professors will ask that of you. And if not that, if you do your homework online, sometimes if you input an answer that's not completely simplified, it could mark it as wrong. So to simplify, we just times these two together, which would give us -3x to the 5th power plus distribute this to the 1 and to the -x would give us 15x to the 4th power minus 15x to the 5th power. And if you see it, this term and this term are like terms because they both have an x and the power of 5. So that would simplify further. -3 minus 15 would give us -18x to the 5th power plus 15x to the fourth power. This right here would be the simplified answer.